Traditional way to draw them in parallel is like this. Again, that's not the only way to draw in parallel, but this is kind of what everybody does. And I have 3 of them, right? 30 volts, 30 ohms, 30 ohms, 30 ohms. Here we got it? So far, do this circuit correctly. Next piece is what's the total current across each resistor? Now, current, I have to drop an electron that leaves the battery, goes whipping around, goes through this resistor, and then goes back home, right? So it's lose all its voltage here, right? So because of that, it's going to go V equals IR for that one. And the voltage would be 30, and the resistance would be 30, so the current would be 1 amp. Everybody agree with that? Everybody with me? Got it. And if I have 1 amp there, how much do I have going through the second one? 1 amp. So I have 1 amp current flowing through that one. 1 amp of current flowing through that one. 1 amp of current flowing through that one. I'm going too fast lately. Good? Everybody see that? What's the total current of the system? I have 1 going through here. It connects with this one. There's 2 here, and then it becomes 3 when it comes back to the battery. So the total system would be 3 amps. Agreed? Now, what's the total resistance? The answer is, you have 2 ways to do this at this point. We're going to do it both ways. We're going to do it the way that Jeremy did first because he discovered that first. So let's do that. Voltage total equals I total times resistance total. Agreed? Right? Total resistance times total current gives you total voltage drop, right? Voltage drop is 30. Current is 3. We just said that. So resistance total would be 10 ohms. Uh-oh. Pausing there. Yes?
Didn't you use the total current? Like that's 3A throughout the whole system, right?
No, it's only 3A during this little stretch here, this stretch right here, but that's what the battery's providing, 3 amps. So that's the total current the battery's providing.
Okay.
That makes sense?
Yep.
Emily?
I just did it the other way.
Well, we should get the same answer, so let's make sure we get the same answer. So that's one way to do it, and then the other way to do it is to go, whoa, 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 I got a way to do this right from original principles, which is 1 over RT. Be careful, people forget to write this 1 over RT. It's weird about this formula. We don't write RT is equal to, we write 1 over RT is equal to. 1 over what's the first resistor? 10, 30. Thank you. Second one?
Oh, you have to do 1 over 3.
Yes, all over 1 over. Now I'm going to do what I just told you we're not going to do in this class. But I'm going to do it anyways because you got 1/30 plus 1/30 plus 1/30, which is what? 3/30. Again, if you just want to slap this in your calculator, totally allowed in this class. Don't really, no, fine. Good. Good job, everybody. That's where you do it. What's simplify? 1 over 10. So what's my total resistance? 10. Look, we got the same answer 2 different ways. That's good news, because if we didn't get the same answer, we'd have to stop doing what we're doing and cry a lot. Got it? So which way should you do it? Either. But you have to be able to do it both ways because of what's coming. So make sure you're not just simply, I'll just forget one way to do it, the other way to do it. You might have to remember both ways. So do start to put it in there. You might even want to do it both ways on all these just because it's fun.
What's the VT thing? Like when should we, is that a formula?
That's the formula we're using on the series all the time. We said the total voltage is equal to the total current times the total resistance. So what's the effective resistance system? The total resistance equals IR.
V
Equals IR, yeah. Ohm's law. Yeah.
Could you do like the voltage at the first resistor and like the R1? It'd still work, wouldn't it?
What do you mean?
Like you could do 1 amp instead of 3 amps for the total system. You do 1 amp out of a resistor, it'd be 1 amp equals 10. Like the resistance
Why 10?
would be 10. Well, because the voltage would be 10. Wouldn't it?
No, it would not be. There's 30 volts being dumped from here to here. Because an electron has to lose 30 volts coming back to the battery. From starting here and ending here, it has to lose 30 volts somewhere. Starting on top of the hill, 30 volts up, ending at 0 volts. has to dump that energy somewhere. And the only place to dump it's here, so it's dumping all 30 volts of that resistor.
So you couldn't do V at R1 equals I at R1.
Well, that's just a math trick. Don't do that.
Okay.
Okay. Do the next problem. Go, 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 go! We got ground to cover. I'm gonna make you really unhappy before this period's over. I'm gonna make you cry and stuff.
Well, it's done. I mean, it's
You already crying? All right, good. Karis. Karis. 5. Here we go. 5. I got a 20 ohm resistor. I've got a 45 ohm resistor. I've got a battery. Notice I'm always drawing 2 cell batteries, even though that's ridiculous. What's the total current coming from the battery? I'm going to be lazy and do it backwards just because that's fun. I'm going to go 1 over RT equals 1 over R1 plus 1 over R2. I'm going to go 1 over...
For what?
Now, to find the total current, I'm going to go find the total resistance first. I'm going to do it backwards from the way you just did it. Just to show you it can be done. Except I don't have a calculator, so I can't do it. Calculator, no calculator. It's okay. Ursula never used her calculator. All right, program momentum. What the heck is that? The heck? RT is equal to 1 over 20 plus 1 over 45. So notice what I'm going to do this time. I'm going to go 1 divided by 20 plus 1 divided by 45 is 1 over RT equals 0.072222. No common denominator, nothing fancy like that. I'll just put it in my calculator. And then I move this up here, so I'm going to divide that by 1. So 1 divided by shift answer, and I get my total resistance is 13.8 ohms. So I haven't answered the first question, but I've already answered question B, right?
Mm-hmm.
So what's the first question? V total equals I total R total. Voltage total is 130. The current I don't know, but the resistance is 13.8. So 130 divided by 13.8 is a lovely 9.42 amps.
Wait, so why don't you just put 65 in for the 13.8?
65? Where do you get 65 from?
20.
Oh, because when you add fractions, it doesn't work that way. Right? You have to get a common denominator and then match up the tops. It doesn't work that way. Yeah, no. Adding fractions don't work that way. If it did, we wouldn't write the formula like this.
Just like from the beginning before you solve for the resistance?
One more time.
Like how would, if you're not...
The other way you can do the problem is you could go, what's the current here, what's the current here, right? So you can go 130. You go B equals IR. That's why I'm doing it now. Shh. 130 divided by 20 gives me 6.5 ohms here. Amps, sorry. Amps, right? And then this way I would do 130 divided by, what is that number? 45? Well, I lost the 5. Divided by 45, and I get a lovely 2.89 amps here. Why doesn't that match? Oh, yeah, it does, but it's off by a little bit. That's kind of weird. Oh, that's because I don't know how to write down numbers. Wait, no, I do. 6.5, 6.5, 2.89. Weird. All right. So now I do the math, and I get what? So the total current would be 6.5 plus 2.89, because 6.5 is going this way, 2.89 is going that way. And I would get the total current would be, whoops, I wrote times, it should be plus. And I would get 9.39 amps, which is some sizable rounding I should have been more careful with, apparently.
13, I think it's because the 13.85, and it's like 8, it would round up to, yeah.
Yeah, well, that's why it has to be, but it's not really, kind of weird. Wait a minute, good?
Yeah. Well, if you only get the 2 significant digits, then it's fine.
It's fine. And I rounded this a little early is what happened there. It's okay.
Where did the 6.5
6.5 was from this direction. I do V equals IR, voltage is 130, currents, the resistance is 20. Divide that across, I get 6.5 amps just going through that resistor.
Yeah, and if you divide it by 13.85 instead of 13.85.
Yeah. That has to match. It's just that was kind of where they were that far off. Not usual. What's the current for each of the resistors? I just answered that question, so I'm done. No, the current to the first resistor is 6.5 equals IR. Current to the second one is 2.89.
Okay.
That's it. Those are the two currents, right? All right, you guys got it? Can do this in your sleep? Go! I'm going to give you a couple more problems before I open the can of worms and make you cry.
I don't have that.
You don't even have that worksheet?
Like I have it in that can of worms.
There's one in the back. I feel like I go back twice in periods. Every so often I'm wrong. So let me check, see if I'm wrong first. Yep, I'm wrong. Thanks for checking it. I appreciate it. Good job. Everybody's yes.
Does power change? Oh wait, yes it does, never mind.
P equals I squared R. Do it that way and you won't have a problem. If you're using P equals IV, you should already be running into places where you got different answers than we got.
Okay.
And you're like, wait, what?
Okay.
Yes. Question?
You use the R for each resistor.
If each one individually, right? If as for the total power, you can use the total resistance that you could solve for by 1 over RT if you wanted to.
Okay.
Or you can do each one individually and add them up, right? Because one's 10 watts and the other's 20 watts, so it's total 30 watts being great. All right, let's save this one.